So for those 2 new people, what we do in this like weekly ship it session is we use AI agents to do operation stuff, like all the kind of like ugly kind of like development related tasks that people don't usually like doing. So all the things other than coding. And we do that with very little minimum preparation. So it's super raw. And yeah, we get to chat about agents, use them, break them in live in real time, and talk about like the architectures and the different things we're trying with like the Stakpak open source DevOps agent. So if you're ready to start, let's go. Later in the end of this session, like Noor is going to post a poll about ideas that you can suggest for the next sessions. Today for this ship it session, like just first let me know if the font is large enough or if I need to increase it again. And like, yeah, the format last time was pretty casual, so you can just like ask questions and we'll discuss stuff. Noor is going to read out loud the questions. So what we're going to do today is deploy something on ECS, on AWS from scratch. And Noor and Mustafa, two of my colleagues, they vibe coded a really ugly voting app. So before the call, I just saw this app the first time, literally like 5 minutes ago, and I very quickly containerized it. So I asked Stakpak, like what we did last time, to create a Docker file to serve this like static app through an image. And what we're going to do now is basically like build this image, push it to ECR on AWS, and then deploy a whole ECS cluster and deploy this on ECS. So that's what we're going to do today. So at any time, if you want to stop me, just ask any questions while we're working. Like the agent does most of the work, so just be talking. So let's start. Okay, so first thing first is we need to build this image and push it to ECR. So we are able, so it's publicly available, and then ECS is able to pull this image back. So what we're going to do now is first create Terraform code to create a public ECR repository called voting app. Then build and push the image in the Docker file in voting app directory. So first is asking to like explore the voting app directory and the Docker file. So this uses like the Docker file is basically an Nginx container, and this Nginx is like serving the static voting app. In production, you would use like a private ECR repository, and then you would add permissions for ECS to pull this image. But now, like since this is like a very dummy app, we're going to use a public ECR repository for demonstration. If we have time, we can turn this into private and I can change it. So you see here, like I created the ECR repository and added a policy. So if you haven't used Terraform before, it's an infrastructure as code tool. And what it does is you declaratively define in code your infrastructure. I'm going to go through the code now. But then when you apply it, it installs the extensions, and here it's using the AWS extension to communicate with AWS API. So everything Terraform does is basically turn this declarative code of what you need on the infrastructure into API calls, and then makes these API calls to AWS to create the infrastructure. And this is much easier than using the CLI, because you can look at your code and audit it, and you can check the code changes and like put it through the code review, standard code review process you already have, instead of having to remember all the different CLI commands you need to run. At the same time, if you make any changes to infrastructure, like if the deployment got broken or something, you can just like apply the configurations, and Terraform would figure out the difference between what's actually live on the infrastructure and between your code base, and just synchronize the difference. So it makes working with complicated infrastructure much easier. So this is a very simple setup for the ECR registry, but as things get complicated, as you would see, it would be more important to use Terraform. It's like more useful. Yeah, so still downloading the AWS provider. Ah, it's done. Okay, great. So now it's going to plan and apply my code. So planning basically shows you the diff of like what's the difference between your code and the cloud environment. And you can see like there's nothing, so it's going to create everything. So basically two things, like the repository and a policy for the repository. And now it's going to apply the code. And that's it. Now we have an ECR repository, and this is the output. So like this is what like the URL of the repo is called. Yeah, so this is the ID, ARN on AWS, and this is the repository itself. Okay, great. Now build and push the Docker file to this new repo with the latest tag. So I printed out the commands, but I wanted to run the commands. So here what it does is like get the login credentials for the ECR repository to be able to push the image, and configure this with the local, like my Docker client. So usually you would have to look this up in the documentation, but I keep forgetting about this, and that's what's cool about like the agent. It like just comes up with this stuff for you. So now it's building the image. Done, because this is a very simple image, and then it's going to push it to ECR. So here it's tagging the image with the remote repository tag. Then it's going to push it. And Docker push. Please feel free to ask like any questions while we're waiting for it. So like, who among you have ever used like ECS? Hey, Ray, nice to see you. Okay, what do you hate about Docker? It's pushing. So this is the worst thing about DevOps, like, or operations in general. Like most of the time you're just waiting. Okay, we pushed the image. Amazing. Okay, great. Yeah, so we just like pushed the dummy like voting app into an ECR repository so you can use it. So now like, yeah, we can copy this over. We're gonna just leave it here. It doesn't matter. Yeah. So let's start another session to create the actual ECS cluster. So Stakpak, okay. Use Terraform to create an ECS cluster with audit logs enabled. And the module that can be used to deploy ECS services on this cluster. So here, like, the agent is going to see that there's already some Terraform code locally in my file system, but it's going to do like additional, like more exploration, and then it's going to add like the additional Terraform code to create the cluster. That's why I said it didn't matter, like that we keep the ECR repository URL, because it's going to figure it out. Okay, so here I come up with some instructions to the generate code tool. So this is a specialized tool we have at Stakpak that generates like high quality Terraform, pulls in the official documentation and the schema, and then based on this schema it generates configurations. And here, as you can see, like it's going to create this folder structure with the ECS service module and the ECS cluster and the root Terraform module. If you have some time at the end, like after finishing the deployment, I can actually show you, like give you a sneak peek of some of the things we're working on at the moment. So one of the interesting things we found out by working like on DevOps tasks is that like the agent usually has to do a lot of like asynchronous tasks, for example. So starting port forwarding and then issuing a command through the port forwarding command that you issued like in the background. So one of the things we're working on now is like asynchronous command execution. So the agent is able to like dispatch an asynchronous background task and then do something else and then go back to check on the background task or like work between them. So this is different from like sub agents because you have to run these commands in parallel and do something else like to unblock yourself. So this is something we've been experimenting with, and I can actually show you guys if we like have some time at the end and how it would look like to get your feedback. Oh, this is so slow. Okay. It's a lot of code. I'm trying to get to the top of the file. Okay, here it is. Okay, so we have these files, the variables.tf, outputs.tf, ECS cluster, and the 3 module files. So the variables defines the environment, project name, VPC CIDR, availability zones, public subnets, private subnets, cluster name, log retention days for like the audit logs, because I asked it to create some like to enable audit logs in ECS, and then some outputs. And then the cluster itself, it creates a virtual private cloud, like a VPC for the cluster itself, an internet gateway so it can enable to access the internet. Like you need an internet gateway to have like a public subnet on AWS. And configures the public subnet to connect to the internet gateway, creates the private subnets, creates an elastic IP for the NAT gateway and a NAT gateway. This is needed for some services. For example, like if we're trying to create a cluster and then access parameter stores like the AWS service to store parameters or secrets, you can't do that without an NAT gateway. And the routing tables for the public subnets and the internal subnets, and the routing rules, and a security group for the ALB, so you can access the cluster, and standard ECS permissions, like all of the roles and dependencies you need to run ECS, task execution role, IAM role, CloudWatch log group with the convention like ECS expects to dump the other logs, and the actual ECS cluster, which is like 10 lines compared to all the dependencies you have to run to be able to have this cluster. And it's connected to the log group we created earlier, and the variables configuring like the proper tagging, and a load balancer, and load balancer target group to point it to a service. But like we have to have a service for this to work. Like we're going to see how it like pans out. And a listener for HTTP, more variables for the ECS service, outputs, and the ECS service log group, and the target group for the ECS service, task definition, and auto scaling. Okay, amazing. So an auto scaling policy for CPU and memory. Yeah, and that's it. So now let's instantiate this ECS our main module to deploy the image. Should deploy the latest image in our ECR repo. You guys have any questions so far? Okay. So here you see like the generic code tool takes in some context, like the existing files, and a prompt the AI. So like AI is really, like the LLMs are really good at prompting LLMs. So like this is a very detailed prompt on what it expects to do, with some like sane defaults that we can like tweak later to deploy the service, modifying these files. So you can use, like, you can edit like generic configuration two ways. Like you can use the generic file system like editing tools available like the Stakpak agent, or you can use the generic code command. Usually generic code command is more accurate for specific configurations like Terraform and Kubernetes, because we're optimizing them internally. But like it's still fine to make edits like without using these tools for quick stuff. Yeah, so it updated the LB. So let's see what it did. So it applied some edits to some files. So in the voting app service, it pulled the ECR image and created a target group with the app name and a listener rule to forward traffic when we match specific like path patterns. So we can tweak these later. And then it created a module for the app service. The module we created earlier, just added it here. Okay. Now the user wants to provide, okay, let me first create a usage example file and then update the scratchpad for the final report. Okay, so it's trying to create an example usage. No, we don't need that actually. So let's skip this. Terraform code to deploy the cluster and the ECS service. Okay, it found an issue. Yeah, we're misterraforming it. Okay, so we have a deprecated attribute and an unsupported block. So it's fixing the deprecation error first, and then checking out like the unsupported block. And check the module to see like the correct way to define this block. Searching documentation. Because we got it wrong. Here you see like we got the syntax for the deployment config, this one, wrong. So it's looking up the documentation to figure out like the correct block structure. So the search doc tool is actually a research agent, but this research agent doesn't search the entire web, but like a set of whitelisted official documentation URLs to make sure like the quality is higher. Because this is also like a security vector, like people can inject prompts from random like web pages when they're used in search. So we're still looking into ways to make this more secure, at the same time not limiting the agent in specific pages, but it's tough, like, yeah. Okay, so based on the docs, the correct syntax for ECS service deployment configuration in Terraform is not using deployment configuration block, but rather individual attributes. So it's breaking them down. Now let's validate again. This time it worked. Great. So much effort to deploy something with ECS. And ECS is significantly easier compared to Kubernetes. We're going to be waiting a lot of time for this to apply. Like, like just even listing the changes is taking too long. Okay, but it got like the right image. This is the one we pushed.
Now he's asking if we fix the bug where when the agent creates files, we somehow can't find them
Yes,
from the
so
last session.
yes, exactly. So like this was a very interesting bug.
There was no bug.
Yeah. So what happened is like no, we actually had a bug. So the bug was if we start like the so Stakpak, the agent itself is built as an OpenAI compatible client, an MCP client, and an MCP server. So what we do is in every session we start an MCP server with a random port. But what happens is they're usually like you can end up in a state where you see that a port is empty, but you don't claim it, and then when you start listening on the port, so it can happen that there can be a collision between two processes to listen on the same port. So your client in one instance would be connected to another MCP on another port. So this is a major, like it's a security issue, but it's also a very inconvenient thing because like it's very finicky. Like if you're running multiple versions of the agent, like multiple instances of the agent at the same time, they would connect to each other's MCP server, which is crazy. So this is what happened last time. Like it connected to another MCP server of another instance that was running in another shell. And so the MCP server was doing the actual file writing. So it was written in another completely different directory. So to fix this, we did a couple of things. Like the first one is when we find like the correct, like when we find an empty like port, an available port to listen on the MCP server, we just claim it, we just start listening on it, and then pass this listener to the MCP server to mount like the routes on top of it. So we avoided this like sort of like race condition where two MCP servers would try to listen on the same port at the same time by claiming the port. So it's not available anymore. So this solves the collision issue and like or the race condition issue, but it didn't solve the security issue because anyone can connect to anyone's other MCP server. So what we did here is we generated like a bearer token. Whenever you launch the Stakpak agent, we generate a new token. And this token is like a pre-shared secret between the MCP client and the MCP server running on your machine. So anyone trying to connect to the MCP server without this token won't be able to connect. So even if there's a port collision because of the pre-shared secret, this collision won't happen because the server will not allow you to connect because you don't have the right password to go through. So we resolved the race condition in the MCP server ports, and we also added a pre-shared secret as an added like security layer on top. So no one would be able to connect to your existing MCP server while you're working. Yeah, if I didn't explain that clearly, please tell me. Because then I'd like just spin up like a diagram and start drawing stuff. But it was a very interesting bug. I think I messed something up, so we can actually we can start from checkpoint or just check the session. Okay. I think the command was too long. So what we could do is we can try something new, like we can fall into shell mode, for example. And in shell mode, we can do terraform plan, for example. So this gives us the ability like to drop into a shell and would still share this context with the agent afterwards. I think that like the amount of lines printed is too much, that it's breaking shell mode. This is a very interesting edge case we have to test. There's actually an error. Okay, cool. Okay, so what happened here is it exited with an error, but like the output of the command was too long. So instead of like cluttering the context window, we just like dump it into a file. But now the agent is aware of where this output was written, and it's trying to check this file to see the exact error output. So this is how we handle like the trade-off between, instead of including like the whole command line output in the context and like cluttering the context, we just write it into a file and tell the agent that it's in the file. The full result is in the file, so it then can like look into it line by line.
Ali is asking if you can explain the bug in a diagram.
Okay, yeah. I thought so. So I want to kick this off to apply, like fix the bug and apply. Okay. So I'm just giving it a hint. This is also something like we've found happening frequently in operations, is that like a lot of commands run for a long time and they like dump huge amount of text. You have to go through them. I actually ask it to tail it. That would be easier. Yeah, okay. It's trying to figure out like how to tail the file, which is very stupid. Okay, now it figured out how to tail a file. Why are we not getting like the rest of the output? That's weird. No, I think it's going off course. So what we can do is we can take this. Maybe you have a bug in how like we dump this in a file. And then can resume the session and just give it like the error. Okay, we officially broke the TUI. Amazing. I mean, that's why I love this sessions. These sessions. Okay, it just doesn't care and keeps going. Okay. I can start here in a eraser diagram. Wow, this is so bright. Okay, so when we start this Stakpak agent, you have two components in like when regarding the tools, because like this is how we decided like to create the standard for calling tools. So this is the whole agent. So the agent inside is made up of two parts. One part is the actual an MCP client. So MCP is a protocol developed by people at Anthropic to be able to add like additional capabilities to existing LLM applications. So if you have an application, you can just like connect it to an MCP server and just expose existing like prompt templates or tools that the client can self-discover and then use. So the client here is connected to the actual LLM on our server. Here. But it's also connecting to local MCP servers running on your machine. So this is all your machine and this is like a different like security context, or like the sort of like the cloud where the LLM is hosted. Okay, so this is running on your machine, and there are multiple ways. These, like, they call these transports. They can work in multiple ways. There's the stdio transport, which is like just basically running a command and piping in stuff and getting stuff out. And there's also a server send events kind of transport, and there's like streamable HTTP transports. But I mean, server side events is also HTTP, so you can just say like there's HTTP and stdio. And stdio is pretty cool. I mean, most MCP servers work with stdio, just running the MCP server as a command line, giving it input as JSON in JSON RPC, and then getting the output and just feeding it to the user. This includes like discovering new tools, discovering prompts, or actually calling the tools. But if you want to stream back results, like what we did with the tool calling, you would need to have an HTTP sort of transport protocol, so then you can use server send events to stream the response. And you've seen this like in Stakpak here when we were doing like a long running task, and this task was streaming in input. This is streaming the tool results. So we're sending the tool request, and the server is doing something and streaming back the output or the feedback as it's going. They call this like progress notifications. So to be able to add this feature, like streaming feature, because there are a lot of like operations in DevOps when you're building, for example, a Docker file, you wait a lot of time, and we can't just let developers wait while this is being applied. We need to show them some sort of progress. So we decided to use the HTTP transport because we wanted to do streaming. So if you support the HTTP transport, you have to run the MCP server as a standalone HTTP server. So what we do in startup is we just spin up the HTTP server, serving like the MCP, supporting the MCP protocol to serve this to the client. And if you're running multiple instances of the Stakpak agent in parallel, so you have, what you end up having is two CLIs connecting to the same LLM, but you have two MCP servers. So if this MCP server is listening on port 8080, for example, and this MCP server ending up trying to listen on the same port, it will just fail. So this would crash or listen on a different port, as we like coded it to do. But like, what happens if the client starts connecting to the wrong port? So instead of connecting to 8081, for some reason a bug happens, and this client connects to this port, or like this other MCP server. So the MCP server, remember, is where the tools are implemented. So if you're having like the local file system here, which is like, for example, home George 1, for example, and it's working in this working directory, so it's writing files, reading files from this directory. And this other MCP server is working in a different directory, like George 2. What ends up happening here is, although you started the client in this directory and you're talking to the LLM in this directory, the LLM itself doesn't have access to a file system. Everything it does that affects the external world is done through the MCP server. So what happens here is you keep issuing commands, you keep working, and the files are being written in a different directory, not the one you're actually at, because your client is connected to the wrong MCP server because of port collisions, for example, or whatever happened that resulted in this like very sad scenario. So what we did differently here is we made sure to avoid having these collisions, so the client always gets the right port, so it's not connecting to a different server. But we also added an authentication layer. So even if the client, or like any malicious evil client, I don't know, like if we have here like emojis, like evil emoji. Are there emojis here? Yeah, okay, cool. Yeah, so if you have like a sad, evil, frowny emoji here that's trying to hack, like connect to the MCP server to be able to write to this directory, this will fail. So this would not work anymore. And you would get like a 403. Oh, okay. Where the server would shout at you, okay, you don't have the token, so you're unauthorized to be able to access this server. So the first thing fixed with it is preventing the collision, but then we added another layer of defense, which is like requiring authentication with a pre-shared secret. So whenever the client is started, the process of the agent started, a secret is generated securely, and it's shared between the client and the server, so they are able to connect. So this client wouldn't be able to connect here again, so it wouldn't be able to write in this directory. Yeah, I hope this explains it. Yeah, is this clearer? Yes, we found the files we created last session. They were in a different directory, exactly. Yes, you can prompt Stakpak and ask it about like current directory. What's going on? Okay. Whoa. Okay, let's start a clean session. So apply this Terraform. Yeah, okay, amazing. So because we didn't memorize this, it's doing the discovery again. Still have 15 minutes. Amazing, the plan passed successfully. Now we're creating stuff. Can you please link the tool website used to create the diagram? Okay, it's called Eraser. Looks like we have an issue with streaming huge amount of text. Still have an issue. Vibe coding Terraform. Value depends on resource attribute that cannot be determined until apply. Yeah, I think that's the main issue. Is like we're trying to create a target group that targets an ECS service, while the ECS service is not ready yet. Ah, I see why this was not printed. So it doesn't, like, Terraform prints the error, like it doesn't print an STD out. So that's why this was an issue. Like this was not like in the the command dump file. That's why it went crazy. Terraform apply error. And then it's done. Apply text. Okay. Now we got to show it the error. Yeah, this is crazy. We have to fix this. Can be determined the apply time, then it look at the main file. Okay. So what is the proposal? So target group RN, target group, create target group. Okay, so move the target group definition into the root module, because we need to create the ECS service first. Yeah, there's a circular dependency. How much time do you have left? We have 9 minutes. Okay, let's see if it fixed that.
Harry is saying dependency management is so painful.
Yes, and then we end up doing a lot of like errors. While we're fixing this, main has not been declared in the module moon. Okay, yeah, so it removed it, but forgot removing a dependency. It's stupid because it didn't use the editing tool we built internally. It just like went ahead and like just removed the resource. Okay, so let's dump this again. So I'm going to try until we run out of time. And we need to figure out a better way to be able to feed in like the standard error into the file, so then it's able to check it out. Can actually try again, like so run Terraform fix the errors. Ah, it's very stupid. Finally, you can see the error.
Mustafa is asking how to make sure the agent is not messing up my AWS account,
Yeah,
like creating unneeded resources.
yeah, we're going to get into that later. Like, we have to make this work first. Okay, now it's removing the extra depends on. Finally can see it. Yeah, now have valid code. Now we have to apply it again. Okay. Ah, so much text. I think it's blocked because it's expecting me to write yes, but this is not like non-interactive. Like, I can't write yes. Now I can write yes. Okay, so created the task. I think it created the cluster area. No, it's still waiting for the cluster. Okay. Interesting. So ECS tasks can be independently created even if the cluster is not there yet. Interesting. So HTTP response says code 400. API error, invalid parameter, US East. Okay, so we're creating it in an invalid zone. Interesting. I love breaking our agent live. It's therapeutic. Wow. Yeah. 4 minutes left. We're running against the clock. Let me know if you have any questions. Did it see the errors? I think it should have seen the error. Yeah, it should have seen the error. So here's a rotor-proof. Interesting. So the Terraform binary errors were not included here. Maybe I think we might have a bug related to like piping out the standard error because it didn't see the error. Interesting. Okay. Yeah, we'll have to fix that. So you see, like it ended up like the last thing we got here is like the creating kind of like logs, but we didn't get the actual error. I think we're going to run out of time. But yeah, 2 more minutes. Anyone have any questions? Since like this kind of like ship it mission failed, but like yeah, if you have any questions, just let me know. It's fixing the regions. Cool. Apply again. Now creating the subnets worked. I'm curious if we're able to make it in the remaining 1 minute. Now creating the ECS service. And the ALB. I really wanted to show you how horrible the app we vibe coded looks like. Come on, AWS. Yeah, I mean, I'll keep working, like it's almost there. But like, I mean, the main challenge is to get something real done within an hour. And yeah, it's been an hour. Last time I built an ECS cluster with proper audit logging, access control, secret management, DNS configurations, and TLS took me half a day. So like this is a stretch, but let's see like how far we can push it.
With Stakpak or without?
With an older, less capable version of Stakpak. I mean, if you're doing this without any like AI coding assistance, it's just like going to take at least a week. I mean, the main issue is forgetting about all the little parts, all the dependencies that you need to get something working. So like to just deploy a single service, you have to create like 30 different resources. It's crazy. I mean, AWS is crazy complicated. I mean, that's why you get a startup every couple of months trying to reinvent AWS's UI. And AWS is not doing anything about it.
I mean, they have plus 200 services.
Yes. Creating. Okay. Great. Whoa. Amazing. So can we copy this? Okay, it fixed the issue and applied it. Now let's test the service. Usually things don't work. Like it has already autoscaling configured as well, but like things usually don't work the first time. So let's do some health checks. It's doing the health checks. Great. Okay. Okay, it thinks it's done, but no, I'm not going to leave it at that. Like I'm going to bully it into testing the service to make sure the endpoint is working. So we're 3 minutes late. Well, let's see if we can do this in the remaining 2 minutes. Okay. Test the endpoint to make sure you can access the service. So it says that the ECS cluster might not be ready yet. It's not, but I'm asking it to check it. "503 service temporary unavailable." This means the container is not running properly. So now it's going to start debugging. Getting the service name, the task ARN. stopped deprovisioning. I think this means that the service is not healthy. But let's see if it's going to figure it out. So this happens in ECS when you're trying to start a service, but at the same time, like, it's not able to respond to the health check. So you need to define a proper health check so the load balancer would figure out that the service is actually running and it wouldn't kill it. It's trying to get the logs. Okay, Docker entry point exec format error. Here. So it could be the health check, or it could be the app itself is not running. Let me update the scratchpad with the current. Okay, so let's see. This is a classic error that occurs when there's an architecture mismatch between the container image and the target. Ah, okay. So I built the image for a macOS Apple Silicon, but ECS runs on x86. So this is the issue. I built the image for the wrong target. Okay, so rebuild the image for the right architecture and push it to ECR. So this is completely my fault. Because I'm using, like, I'm running an Apple Silicon. If this works, this is going to be my record. I've never deployed something on ECS this fast. I really hope it works. Okay. Logging into ECR. Now building for multiple platforms. As you can see now, it's building for Linux and AMD 64. So this one, we don't need this one, but, like, yeah, it just decided to do it anyway. Pulling an image. We're almost there. It's done building. You guys want to talk about anything while it's pushing the image?
He's asking about what Mustafa asked about.
Yeah, we can do that. So I'm planning to do that when we try destroying our infrastructure. So Terraform is great because you can create everything with a single command, but you can also bring everything down with a single command. So I'm going to show you this live, if you stick around to the end. How Stakpak is going to save my AWS account. I think it's going to double check the ports. So it did something really cool. Like, we haven't talked about this, but it did something really cool. Like, it configured auto scaling policies for CPU usage in memory. So whenever it exceeds a specific memory, it just like gives it more resources, auto scales, like creating multiple instances. And whenever it exceeds a specific CPU threshold, it creates multiple instances, which is amazing. So this is the health check. I thought originally was the issue, but we're going to test it again now. We need to fix the port mismatch. So while reading the Docker file, it figured out that the container is actually racing on 8080 by default, not 80. So it's fixing the port issue as well, which is incredible. It's also going to change the health check, which is amazing. So this is another likely cause of the ECS task keeping restarting is you got the health check endpoint wrong. This is the first thing that comes to mind because like it happened to me like a million times. Okay. So I think we hit a bug here. So I'm just going to try this. Now the endpoint. So it's going to change this from dash health to dash because we don't have a dash health check endpoint in Nginx. And the load balancer, as I explained earlier, like uses this, like pings the health check endpoint to make sure the service is running. And if it's not running, just like restarts it. So it's very important we get this right. Okay, we're 12 minutes overtime. Yeah, cool. So what do you mean by the before and after the AWS resource? You mean like the created resources on the cloud? Like before and after what? It accidentally like changed the port 2 times. We're almost done. We're almost there. Applying again. Ooh, so it's recreating the task definition to use the latest image when the agent is making changes on AWS. Yes, it is. So like, yeah, I mean, if you used Terraform before, like Terraform, every single time you're doing anything, Terraform just shows you the changes you made and everything that changed. Like, because we're applying everything through Terraform, so you can easily check the resources being created by just listing the Terraform resources. So it's deleting the target group and recreating it again with the correct health check. So that's one of the benefits of using Terraform. Like you already have like something keeping track of the things you're creating on AWS. You can do this stuff without Terraform using the agent alone, but then you don't get this code at the end that tells you like the whole picture, like the bigger picture. We can take more questions while we're waiting for this. Like, yeah, thank you for being patient and waiting this far. If you have any like technical questions about Stakpak, we'd love to answer this. Yeah, it's really good at Bash. I mean, it's good at Bash because Bash is very old. So whenever it gets something wrong at Bash, it's usually because the command it used in Bash is actually broken, or like it changed. For example, like the older models tend to use docker -compose a lot because the newer Docker compose is actually docker space compose. So it messes that up because a specific CLI actually changed. But with the Bash syntax itself, it's really good at Bash. Okay, so it hit a snag, is that there is a collision with the target group, so it's not able to delete the target group. Because it's currently in use by listener rule. So this happens all the time with Terraform. So what Stakpak is doing here is it's surgically destroying the listening rule from the state that is creating this like circular dependency. So it's then able to recreate the target group. So like Terraform is not perfect. There's a lot of these like circular weird dependencies, and sometimes you just need to have to get your hands dirty and do these things. So this happens a lot in real life.
Ali is asking if if the agent is connected to the official docs.
Yeah, it is. It is connected to
so it knows the right Docker command.
It is connected to the official docs, and sometimes you'd see it like, sometimes it looks up the documentation on its own, but sometimes you have to ask it to do some research before actually or checking the docs before doing anything. But it is connected to the documentation. I mean, that's the main reason why it generates better Terraform compared to using an LLM or ChatGPT on its own. You can see this when it's like invoking the search docs kind of tool. So when it calls the search docs tool, what's happening in the background is it's looking through documentation. So now it's checking the service health check again. Okay, it's active, but 0 are running.
Ali is asking if it's using context 7 MCP.
No, we actually tried using context 7. It didn't work out well because context 7 feeds you code snippets, so it's good when it's coding, but it's not good when you're issuing command line, like CLI, using CLI tools or the command line, because context 7 actually ranks code snippets higher than regular text, and most DevOps configurations are actually like using the actual like textual part of the documentation. So context 7 works well for code generation, but it doesn't work great for DevOps. Okay. So this is the ALB address. Whoa. It's really hard to copy stuff from the TUI because it keeps moving. Okay, it's healthy. Amazing. Woohoo! It's connecting. I remember it added like a routing rule or something. So it shows that the target is healthy, but the LB is still reading 503. Go and check the routing rules. I mean, this is the first thing I guessed, like the routing rules are broken. Yeah, it's really good. See, so it's using dash vote dash routing. Let's see if that worked. So the architecture issue is fixed, the port configuration is right, the service is reachable, but it's trying to change the route path. Okay. Testing the vote, we get 404, change me serving. Okay, cool. So sometimes this happens and like Claude hallucinates. So we definitely need to add like a retry button or something, because now I just have to exit and then write Stakpak and go to like retry the previous checkpoint. We built an evaluation to root these things out, and it turned out like Claude is just not reliable. And until we implement like the detecting this and like just auto retrying, we'd have to retry manually. Now it's going to fix the routing rules and reapply. This is like, I didn't think this would be realistic, and we wouldn't get these like a lot of these issues, but like every single issue we found today is definitely happened with me before, like getting the routes wrong, pushing the wrong architecture, and getting the port wrong. Like all of these things happen in production. So I'm really happy like we got to to get like a real taste of how like doing DevOps would look like, and we didn't end up Googling not even once. Okay, Claude is definitely not reliable. So initially when we were using Claude 3.5 or 3.7, they used to hallucinate the tool call arguments a lot. So they're like notorious at that. And now if you look at the forums, like we were just like doing a survey of coding agent hallucinations due to like long context. And everyone is complaining about Claude code. I mean, definitely Claude Sonnet 4 in Claude code, that it ends up messing up a lot. Especially like with longer sessions exceeding, I think 30,000 or 25,000 tokens. Okay. Let's ask it to test the endpoint one more time, because I didn't look into it as it was applying. But yeah, Claude is not reliable. And I mean, we have to add a lot of workarounds. Claude 4 is much better at doing tool calls, but we found out that it tends to hallucinate sometimes tool calls. Like they call it phantom tool calling, that it assumes it called the tool and returned the response, but it didn't do anything. So it's worked. Ah, it's alive. Yeah, finally. So I need to get the LB endpoint because I missed that. I didn't copy it. But when we have that, the voting app would be working. Where's the address? Oh, come on. Ah, okay, here it is. Oh, it's live. Yeah, so this is the LB serving the very ugly voting app. So the best movie plot twist. No, let's do it again. Best movie plot twist. Definitely Fight Club. Yeah, but I mean, these things, like, they just burn the plot twist. So, I mean, so if someone didn't see any of these, they would just know.
Salam is saying Shutter Island.
Yeah, I mean, but like Fight Club is like like a like kind of a mother of all plot twists. What else do we have here? So like worst movie ever made, best TV series finale, superhero movie showdown. Okay, so best TV series finale. Yeah, Breaking Bad. I don't even have to look into like the rest of them. Yeah, so I'm going to share this with you. I don't think if you vote it would work because this is all like local, so it doesn't have a central data store.
Ali,
Yeah.
Ali is asking which LLM are we currently using.
So we're using Claude 4, as you've guessed, like, and a couple of OpenAI models as well. So we keep changing the model. Whenever there's something better, we just like swap models. But like we use, like, for example, like now our prompts and everything is fine-tuned for Claude Sonnet 4 because it's the best at coming up with commands and writing code. So Mustafa was asking about like trying to destroy stuff. So if we do terraform destroy here, so it would basically allow us like to destroy everything we created. In a single shot, you can just like blow up the infrastructure, destroy 37 resources. So this is pretty dangerous, but like we created something called Stakpak Warden, which prevents the agent from doing similar destructive operations. So let me try this first. So we're going to destroy the cluster, but like let me first show you how it would do that, how it would prevent the agent from destroying your infrastructure first. So here, let's mount my AWS credentials because Warden will wrap the agent inside a container and then control what it would be able to do. So here I'm going to mount my AWS credentials to home agent. So you can see this image on like our GitHub repository, but here, yeah. So what I'm doing is I'm mounting my AWS credentials and running Stakpak within Warden. Okay. Forgot to add a V. So this is the basic command structure, like how you would use Docker. So what Warden is doing is it's spinning up a container, running Stakpak agent within the container, and then controlling what the agent can and cannot do. So even if the agent, as you were going to see now, is trying to destroy the infrastructure, it wouldn't be able to. I think I missed something, like we don't have access to because this is a container, we need to have access to the local Terraform code. So let me mount this as well. So here, home, so agent, and yeah, I think that's it. I forgot the V again. But this time is going to mount it in write mode because the Terraform state file is local and Terraform would need access to it to be able to do stuff. So spinning up the Warden guardrail again. And now if I do Terraform, destroy my cluster with Terraform destroy. So now it's going to plan destroy. Okay, what happened? Oh, we forgot to init. Just wait for it. It's because we're running inside the container. So Ali, what are you working on? I mean, you're asking a lot of questions about like LLMs and agent design. Yeah, most of the work we're doing is just like providing it with the right context. in like your local context and like documentation and other external stuff. Okay, so now it's ready to destroy everything. Yeah, so this is the most dangerous Terraform command. There's destroy and auto approve and like break everything. So yeah, so as you can see here, like first thing it tried reading to synchronize the Terraform state, but then everything broke. I can't do anything. So here, whenever it tries to do like a post request to AWS to destroy something, Warden just blocks it. So here, if you can see, like it's not going through. So the Warden proxy is just like breaking the the requests. Yeah, it looks ugly, but like if you try to do the same here, so Terraform destroy without using Warden, it will work. So now this. So now destroy works and is destroying everything. But if you're trying to do this within Warden, Warden would just stop the agent from breaking your infrastructure. And this is done deterministically. So every single time we're trying to do a destructive operation, it would just stop. Yeah, I think that's it. So it took us, we went 30 minutes over time, but we deployed an ECS cluster with a workload, containerized the workload and pushed it, and debugged like 10 or 20 different issues you need to like, yeah, deploy the app. Yeah, now you can try the ugly app. Yeah, exactly. Yeah, because we destroyed everything. But yeah, I mean, the cool thing about Terraform now is you can just like do Terraform apply and you get the whole thing online again. But yeah, that's it all. Yeah, if you have any questions, just like stay on Stack and on Discord and text us on like the text channel. Otherwise, I think Noor is going to send you a link so you can choose something we can work on and the next ship it. But yeah, that was all. Thanks. Yeah, thanks Ali so much for your patience. Mustafa, Salam, and Joe for joining in late. Yeah, it was great being with you all.